What if I told you that millions of Americans drove cars with features that could turn deadly in seconds, and nobody thought twice about it? Steering wheels that could impale you in a crash. Fuel tanks placed where a single rear impact meant fire. Windshields that shattered like knives. These weren't cheap experiments. These were Fords, Chevrolets, Mercedes-Benz, family cars parked in driveways across America. Back then, these features were completely normal. Today, they're illegal. Some were banned quietly, others only after public outrage and devastating consequences. But every single one of them was hiding in plain sight in the cars your parents drove, your grandparents trusted, and maybe even the ones you once admired at a car show. Stay until the end. The last one will completely change how you look at classic cars forever. Let's start with something that looks simple: the steering column. In older cars, the steering wheel was connected to a long, solid steel rod that pointed directly at the driver's chest. Nobody questioned it. It was just how cars were built. But here's what happened in a front-end crash. The engine, crushed backward by the impact, would push that solid rod with tremendous force straight toward the driver's body. There was no break in the column, no fold, no give. It moved like a spear. Thousands of drivers suffered fatal chest injuries and internal trauma from this single design flaw. The worst part? The outside of the car sometimes looked almost fine. People would walk past the wreck not realizing what had happened inside. Engineers eventually developed the collapsible steering column, a system designed to fold and compress during impact instead of transferring force into the driver. It sounds simple now, but it took years of fatal accidents before the industry was forced to change. Today, any new vehicle sold with a solid, non-collapsing steering column would be immediately illegal. Now look inside a car from the early 1960s. What do you see? Shiny chrome, polished steel, painted metal surfaces everywhere you look. It was considered the height of style and quality. It was also one of the most dangerous environments you could put a human face near. In a crash, even a relatively minor one, passengers were thrown forward into these hard metal surfaces. No padding, no energy absorption, nothing soft anywhere in reach. The dashboard was essentially a steel wall at face level. Broken teeth, fractured eye sockets, skull fractures. These injuries were happening in crashes that a modern car would handle with barely a scratch. Seat belts weren't even standard yet, so passengers had nothing stopping them from launching forward. When safety researchers finally studied the data, the results were undeniable. Car interiors were injuring people all on their own. Laws were introduced requiring energy-absorbing materials throughout the cabin. Today, every surface near a passenger must meet strict padding and impact standards. A fully metal dashboard would never pass inspection. This one might be the hardest to believe, but for decades, cars were sold with no seat belts at all. None. You simply sat in the seat and hoped for the best. If a crash happened, physics took over. Your body kept moving at whatever speed the car had been traveling. Nothing stopped you. People were thrown through windshields, ejected from vehicles entirely, killed in crashes that a seat belt would have survived easily. When governments first proposed making seat belts mandatory, there was serious public resistance. Some drivers argued it took away their personal freedom. Others said they'd rather be thrown clear of a wreck than trapped inside. These arguments were genuine and completely wrong. The data was overwhelming. Seatbelts were saving lives everywhere they were used. Laws changed. Resistance faded. And over decades, the design improved from basic lap belts to the three-point system with pretensioners that lock tight the moment sensors detect an impact. Today, selling a car without seatbelts isn't just irresponsible. It's a criminal offense in most countries. Some design mistakes are about style. Others are about cost-cutting. And then there are decisions that seem almost impossible to explain in hindsight. Putting the fuel tank directly behind the rear bumper falls into that last category. On certain older vehicles, the gas tank sat right at the back of the car, just inches from the bumper. In a rear-end collision, the tank could be crushed, ruptured, and exposed to sparks from the impact. gasoline would pour out. And sometimes, it would ignite almost instantly. The horror of these accidents wasn't just the fire. It was that people survived the initial crash and then couldn't escape what came next. Doors jammed. Seatbelts locked. Flames spread faster than anyone could react. Here's something that sounds almost too simple to matter: the headrest. Early car seats stopped at shoulder height. There was nothing behind a driver's head. And for years, nobody thought this was a problem. Then crash researchers started studying rear-end collisions more carefully. When a car is struck from behind, the body is pushed forward by the seat while the head, unsupported, snaps violently backward. The forces involved are enormous, even in low-speed impacts. The neck, which is not designed to handle sudden hyperextension, takes the full damage. Whiplash became one of the most common crash injuries of the era. Many people experienced pain for months. Some suffered permanent nerve damage. All from crashes they otherwise would have walked away from. The solution was embarrassingly simple: a padded support behind the head. For most of automotive history, the door of your car was just a door. Sheet metal, a window, a handle, and maybe some interior trim. That was it. No reinforced beams inside the door panel. No side airbags. No energy-absorbing structures of any kind. If another vehicle hit you from the side, there was almost nothing between you and thousands of pounds of incoming metal. Side impact crashes are particularly dangerous because the crumpled distance, the space available to absorb energy before it reaches a person, is much smaller than in a front or rear collision. With paper-thin doors, that distance was essentially zero. Broken ribs, collapsed lungs, spinal injuries. These were common outcomes in side impacts that modern vehicles handle very differently. The glass in early cars was just glass. The same basic material used in windows and bottles. It was clear. It let you see. And in a crash, it turned into something close to a weapon. Regular glass doesn't crack in a controlled way. Under impact forces, it shatters explosively, sending shards flying in every direction at high velocity. Windshield glass would blow inward, directly into the faces and eyes of front seat passengers. Side windows would send fragments slicing through the cabin. Many crash victims in the early automotive era suffered their worst injuries not from the collision itself, but from what happened to the glass around them. Deep facial lacerations, eye injuries, cuts to the neck and chest from glass that flew like shrapnel. The development of laminated glass for windshields changed everything. 2 layers of glass bonded to a plastic interlayer. When it breaks, it holds together. Imagine pressing your brake pedal in an emergency and feeling nothing happen. The pedal goes down. The car does not slow. You're heading toward an intersection at full speed with zero braking ability. This was a real risk in older vehicles with single-circuit brake systems. One brake line served all 4 wheels. If that line developed a leak from corrosion, a crack, road debris, the entire system could fail at once. Complete brake loss. The fix seems obvious now. Build the system with 2 independent circuits, so that if one fails, the other still works. But this standard took years to become law. And then came anti-lock brakes. Before ABS, emergency braking often caused the wheels to lock completely. A locked wheel doesn't steer. The driver could stomp the pedal and the car would slide in whatever direction it was already pointing, unable to turn, unable to avoid the obstacle ahead. Anti-lock braking systems pulse the brakes automatically, keeping the wheels on the edge of traction, slowing the car while allowing the driver to steer. For a long time, the philosophy of car safety was simple: build it strong. Heavy steel, thick frames, rigid construction. If the car doesn't bend, passengers stay safe. It made intuitive sense. It was also completely wrong. When a rigid car hits something solid, it stops almost instantly. But the passengers inside don't stop, they keep moving at the car's original speed until something stops them. And when the car itself absorbs no energy, all of that force goes directly into the people inside. Crash researchers eventually understood what needed to happen. Certain parts of the car needed to be designed to fail deliberately, in a controlled sequence. The front crushes. The rear crushes. But the passenger cabin stays intact, protected inside a strong structural cage while the collapsing sections around it absorb crash energy before it reaches a human body. Hood ornaments were some of the most recognizable design elements in automotive history. Jaguar's leaping cat. Rolls-Royce's spirit of ecstasy. These were not decorations, they were identity. They told the world who you were before you even stepped out of the car. They were also, from a pedestrian safety standpoint, essentially metal spikes mounted at chest height. When a vehicle strikes a pedestrian, the hood surface itself causes serious injuries. But a rigid, protruding ornament focuses all of that impact force onto a single point. The result was predictably and measurably worse than an impact with a smooth surface alone. Walk through any vintage car show and you'll see the massive chrome bumpers that look like they could push through a wall. They were designed to convey power, durability, permanence. And visually they delivered. In an actual crash, however, they did something very different. Traditional chrome bumpers were rigid. They didn't compress. They didn't absorb energy. When they hit something or someone, they transferred the full force of the impact directly. No reduction. No give. For pedestrians, the geometry was particularly bad. These bumpers were tall, heavy, and sharp-edged. They struck people at leg height with enormous force, causing severe fractures and soft tissue damage. Because they didn't flex, there was no deceleration, just a sudden, complete transfer of impact energy into a human body. Door handles. It seems like one of the least dangerous parts of a car imaginable. A small piece of metal. A simple mechanism. On older vehicles, door handles projected outward from the door panel, a firm metal bar that you wrapped your fingers around. Functional and completely logical from a usability standpoint. From a safety standpoint, a protruding metal handle on the side of a moving vehicle is a serious hazard. In accidents involving cyclists, motorcyclists, or pedestrians, these handles could catch on clothing, on limbs, on jacket zippers, and either lacerate or pull a person toward the vehicle in ways that dramatically worsen the outcome of what might have been a minor incident. Before power windows became standard, every car had a manual window crank, a metal handle that jutted out from the interior door panel. You turned it to raise or lower the window. Simple and reliable. In a side impact crash, that simple crank became a serious hazard. Passengers thrown laterally against the door, which happens in virtually every side collision, would strike these hard metal protrusions with their ribs, their hips, their arms. The concentrated force of a metal handle against a rib in a crash caused fractures and internal injuries that a flat surface would not have caused. Safety standards for interior components now require that any controls, handles, or mechanisms near occupant impact zones be designed to minimize injury. Sharp edges are prohibited. Protruding components must meet strict force absorption requirements. Anyone who grew up in the 1970s about station wagons, and they'll probably smile. The rear-facing back seat, the one that looked out through the rear window at the traffic behind you, was a childhood adventure. Kids would wave at drivers. Spend hours back there entertaining themselves. What nobody fully appreciated was how dangerous that position actually was. In a rear-end collision, which is exactly the scenario those passengers were facing directly, they had almost no protection. The structure behind them was minimal. No engineered crumple zone between them and the striking vehicle. Head support was inadequate. Restraint systems weren't designed for that position. A rear-end crash that would be easily survivable for a forward-facing passenger could be catastrophic for someone in that old rear-facing cargo area. Electronic stability control sounds like a technical feature for bad weather, something useful but not essential. The reality is that this system has been one of the most life-saving technologies ever introduced in any consumer product, not just cars. Before stability control existed, when a car began to slide or spin on a wet road, an icy patch, a sudden sharp corner, the driver's only tools were skill and reaction time. Most drivers don't have racing-level car control. Most people, when their car begins to rotate unexpectedly, make the wrong input. They steer the wrong way. They brake when they shouldn't. The car goes where physics takes it. Electronic stability control changes this equation completely. Sensors monitor the car's direction of travel many times per second. The moment the system detects a discrepancy between where the driver is steering and where the car is actually going, it intervenes, applying braking force to specific individual wheels to bring the vehicle back in line. It happens faster than any human can react. Studies showed it reduced fatal single-vehicle crashes by nearly 50%. Save the most important lesson for last. Everything on this list felt completely normal at the time. Every single feature. The solid steering column, the metal dashboard, the missing seat belts, the rear-mounted fuel tank, none of these seemed dangerous to the people living with them. They were just cars. Millions of families drove them every day without fear. And that is exactly what makes the lesson so important. The people who drove these cars weren't reckless. The engineers who designed them weren't careless. Everyone involved was working with the knowledge and standards available at the time. They simply didn't know what they didn't know. Crash testing was primitive. Safety science was young. The data that would eventually reveal these dangers hadn't been collected yet. Every law that changed. Every standard that was raised. Every feature on this list that was banned, it happened because something went wrong, someone studied why, and someone else fought to make sure it couldn't happen the same way again. Classic cars will always carry a certain magic. Their lines, their sound, their simplicity connect people to another era. But next time you see one at a car show, look at it with both eyes open. The beauty is real. So are the risks the people driving them once didn't know existed. And the next time you feel your seatbelt lock, hear your stability control activate on a slippery road, or glance at your backup camera, remember that every single one of those things exists because of someone who didn't have it. If this video changed how you see classic cars, hit like and subscribe for more deep dives into automotive history and hidden facts. Share this with someone who loves vintage vehicles and drop a comment below. Which banned feature shocked you the most? I read every single one.